Доброго ранку. Hi guys. Today we will speak after this morning coffee, breakfast, waking up early to get to the conference. We will speak about serious things, about the future of the web, about what we can achieve with web, and who we are, and who we can be if we do it better. The talk is about applying NASA code guidelines to JavaScript. My name is Denis Radin. You may find me online as a Pixels Commander. I work in Evolution Gaming as a front-end engineer. And before speaking about the future of JavaScript, about the laws and rules of building JavaScript, I would like to talk about the laws of the universe. And if we try to make a look at the nature of the things in this universe, we see that the universe respects unification. Our planet's shapes, laws of physics, physics constants, they're similar everywhere. What Wikipedia says about unification? Unification is an effective method to decrease diversity. Aim for unification is to place elements in particular order, building a strict system which is comfortable to use. Decrease diversity, comfortable to use. So there are 60 of standardized units in this universe. This works for nature, this works for planets, all is being standardized by laws of physics, but also this works for engineering. Unification never stops. It works for engineering, politics, all these unions, alliances, always gets more unified. Every time humanity gets on some new field, on a new industry, we use the whole variety, whole diversity of possible solutions, all crazy solutions we can invent. And then we get to narrower set of solutions. So set of possible solutions becomes smaller. Because we choose only best. Only best solutions survive. Oh, some of you were flying by a plane to this conference, and when you were bored in an airplane, you probably didn't distinguish was it a Boeing or Airbus. Basically, two companies produce passenger airplanes, 90% of passenger airplanes nowadays. Oh, can you distinguish, can you say, is it a Boeing or Airbus on the image? Oh, it's really hard to say. It's really hard to say because of unification. I'm a fan of aviation, but even still I can't. I mean, why this happened? Because the laws of physics, the laws how it's good to build, how it's efficient to build something, are standardized for everyone. And the same goes for the unification, same tending goes for software engineering. We developed software for 60 years, but such a common thing like interface description is still not standardized. It reminds me of the early days of aviation, when we had the whole variety of solutions. So let's try to have a look at the early days of aviation and compare them to such an early days of UI development we have now, and compare early experiments in flights with early technologies we have in a UI development field. Looks like Microsoft Silverlight. Oh, what's that? Adobe Flex? Oh, this one is really naive. I like this one. That's a Java applets. No, that's a Flash. It's almost did it. Like it was flying definitely for some time, and now Java applets. I love this one. That's it. Yeah, so you see, we have some imagination. We are good engineers. So as humans, we are okay with engineering things and inventing new things when we are fresh on the field. So, but then, as we all see, airplanes are all very similar. And the same is going to happen with UI engineering. All planes around, all planes are similar, and all UIs are going to be unified. So, of course, we as web engineers have even no question what is going to be this golden standard for developing UIs. Of course, it's going to be what? HTML, CSS. But then, yeah, I'm a big fan of aviation, and I see that HTML, CSS is super good. I really like it. And what I see is that aviation tends for standardization, UI tends for standardization. At some point, they might meet. It was a nice exercise I tried to make 3 years ago. So basically, this talk is a combination of two. Oh, and together they play well. I mean, they put a question and then answer it. And the first talk was about making UIs, airplane UIs, airplane instruments with JavaScript and HTML. Oh, why trying to do that? Oh, there are some cons, and there are some pros. But one of pros for this is, of course, unification. Then we have a unified language for developing aircraft instruments. Reliability, you can say web sucks, but actually web is very reliable. Tested by billions of users daily, web is good. And accessibility. In the age of drones, it's pretty important to be accessible via network. So it's nice when aircraft instrument can be accessible on HTTP as a website, and then you control a drone via a single-page application. And then unification can save some time and save some resources. And also reliability of a web platform. As I said, billions of users daily open billions of websites. It's super reliable, to be honest. Browser sucks sometimes in early fresh versions, but an overall platform is amazingly reliable. And if we have unified language to develop aircraft instruments, we can establish a component market. So some of you can develop aircraft or drone instruments. Okay, maybe not for passenger aircrafts. But okay, we came to a really nice question here. Everybody of us can develop a flight instrument for aircraft. Probably you have some question in your mind right now, but let's get to it a bit later. Yeah, okay, there was this mental exercise. Can we do an aircraft instrument with HTML, CSS? It was 3 years ago. There is a live demo I can show you because this new MacBook don't have accelerometer in it. But then we tried HTML, CSS driven flight instrument in a real flight over Amsterdam with my friend. It was an altitude of 1,000 meters, and yeah, we tried to use artificial horizon built with JavaScript to basically control our flight. It was okay. It was first ever flight, JavaScript and HTML, CSS driven flight with an airplane. Yeah, what I was considering when developing this instrument. So reliability, memory leaks, that would be a problem. If we have a memory leak during the flight, it will get unresponsive. Then resources consumption, and yeah, just efficiency and reliability. All essential things you can imagine when developing something which should work for a long time, being low on resources. But then the question you had in your mind when I said everybody of you can develop aircraft instrument, something which flight commander control airplane with. Your question was, all right, me developing aircraft instrument? I mean, imagine you fly to Berlin. You get the airplane, you took your seat, and then your neighbor says to you, hey, this is a JavaScript-driven airplane. And web developers did all software. Web developers, like your colleagues. Oh, you're a web developer. That's a web technologies-based airplane. Are you going to leave airplane? Or stay and fly to Berlin on JavaScript-driven airplane? This is a question. And this is basically your question to yourself. And this is your trust to yourself. And this is about what is normal in JavaScript world. This is all about trust. Because what basically happens in this case, you do not trust enough to the standards which you follow, you personally, as a web developer, as a JavaScript developer. Yeah, so if we have a wrong understanding of what's normal, maybe we need more guidelines to get to the point when it would be okay. Let's try to get there and see guidelines used by NASA. Simple of them, they have a 200 pages book for C code, but then there is essential of 10 rules. We'll try to apply them to JavaScript. First, yes, why NASA? Why it's actually not NASA, but JPL. It's a Jet Propulsion Laboratory, which do a lot of unmanned missions for NASA. It's actually very cool. This thing, Voyager, is flying 36 years with the software running for 36 years. Can your JavaScript do the same? But, yeah. It's really easy to understand why this happens with JavaScript and web development. Because the cost of mistakes, the cost of getting error on a page is very low. A user press F5, you are done. Your error doesn't matter anymore. It's not like a space mission. Billions of dollars, or like airplane flights, hundreds of people's lives. And then we see now that JavaScript is getting involved into more and more challenging tasks, and it's expected to be more and more reliable. Oh, my previous job was in Liberty Global, the biggest internet and TV provider in the world. And then there we were developing operation system for set-top boxes, JavaScript-driven operation system. This thing is a TV set-top box, which you connect to your TV, it runs for weeks, months without a reset. So for us it was a challenge to get it running with browser on it. All interface was HTML5 rendered without any resets or stacks or memory leaks or whatever. So we tried to apply NASA coding guidelines, GPL coding guidelines. Let's go through them. Rule number 1, no function should be longer than what can be printed on a single sheet of paper. Oh, that's a very basic rule, and it's easy to follow, saying only students don't know that functions should be short. Of course, a statement about sheet of paper is a bit outdated, but it's easy to understand where it came from. And it came from the early ages of software development. If function doesn't fit a sheet of paper, you are in problem, because then you need to put 2, because all source code was published on basically sheets of paper. And this lady is Margaret Hamilton, just was responsible for Apollo mission source code. So she's really amazing. I mean, this is a source code for Apollo mission. Oh, that's why they were talking about sheets of paper. So rule number 1, we can say, we can rephrase as do one thing. Oh, small functions are easier to compose, easier to refactor, and easier to test. Oh, let's consider this classic example. Make coffee and cook egg. Oh, if you do it in one function, it's first hard to read, then it's hard to compose. 2 small functions works better. And if we have 2 small functions and easier to refactor, we can do it asynchronous by wrapping them in promises and swap them and so on. So small functions are better, more efficient. Very simple rule, which is good to follow. NASA following it. Rule number 2, restrict all code to very simple control flow constructs. Do not use goto statements and direct or indirect recursion. Okay, so goto statements for web developers, direct or indirect recursions. It may sound weird, but basically this rule sounds like predictability. NASA depends on static analysis a lot, and if you do recursions, it's a bit harder to make static analysis because they really do it very hard. And for us, it's not about following this rule literally, because living without recursion for web developers is just not efficient. And we don't use goto at all. But then write predictable code, which is well analyzed by your colleagues on code reviews, and also by static analyzers like ESLint, is what we should do to get our code standards to the next level. So, predictability. If you want to write reliable code, drop the white cool one and write predictable. Oh, that's clear. Be pragmatic. Oh, define coding standard and follow it. I think many big companies do, but for smaller companies, it might be a new thing. Coding standard must have. Use static analysis on Git hooks to support coding standard and reduce chance for defect. Oh, ESLint is amazingly popular today. Oh, there is a whole lot of plugins for all cases. We will have a look at a few of them during next rules. And there is awesome ESLint. You can go through there, and you will see that currently there's a whole bunch of plugins for every task. Maybe there are some exotic ones which fits your project. Collect metrics to keep hand on pulse of your code. Or you can use SonarQube, Scrutinizer, Plato for collecting them. And static types. So currently we start using static types for JavaScript. It's definitely a bliss. For reliability, predictability, it's a good thing to have. Rule number 3, do not use dynamic memory allocation after initialization. Oh, here you also can be skeptic. Like there is only dynamic memory allocation in JavaScript. But what it says actually behind the scenes, respect RAM. So we as web developers do not respect memory. We're saying a JavaScript virtual machine will do everything for us. V8 knows how to manage memory. There is a garbage collector. I don't care. Oh, it's actually not true when you develop a critical application. You would like to keep it running for a long time. Oh, rule number 3, respect RAM, or garbage collector might become your enemy. So, yeah, but do you know what garbage collector is and how it works? Who knows? I think pretty a lot of people know. It's sure, should we go? What's that? Yeah, so basically, if you do not destroy links to some object from the root, then some object might be not clean, because object stays in memory until there is a link to it from any reference to it from any part of your system. And then, yeah, be sure that your objects lose a link from a global object when you clean them. And who knows what's a memory leak? Memory leak. Yeah, it's more than half of people, but still, okay, sorry. There is another problem of web world. But then, if you measure the amount of memory used with a timeline, and then, timeline, you know, it's a performance tab, and you make your recording. Okay, I'll check some slides, and you make a recording. Oh, where is the memory? Nope. So yeah, if amount of memory grows and then drops with time and then grows again, but every time it drops but then grows a bit more, it means that somewhere it's not been cleaned. This drop is a garbage collection, and then after it grows more and not being cleaned completely, so-called sawtooth pattern. So here it grows normally because I use just more slides and so on, but if it drops and grows more and more and more, then it's a problem. There are more patterns for that, and yeah, this talk is not about just memory, but that's one tool you can use for tracking memory. And the second one is audits. So, oh, nope. Sync DevTools memory. So, yeah, you can take two snapshots of a memory, of a JavaScript heap. Yeah, I see. Tell me if there is a problem of seeing something. So yeah, you got a first screenshot, and then, so yeah, it's DevTools, memory tab, then take snapshot. You do the one snapshot, change something. So your application performs some actions, right? And you do a second snapshot. And now here we see a drop down. Now there is a summary name, summary label. And instead of summary, you can take containment, comparison. And then you will get a comparison of first snapshot and the second one. And you can see what's the difference of your JavaScript heap and the whole state of memory in your JavaScript engine. And then based on this difference, you can see what's been initialized. So you did some actions in your system, and then you may take approach of 3 snapshots. So you do reverse actions. So for example, you switch to a 5th page, and then you change back to a 3rd. And you do one screenshot in the beginning, second screenshot when you get to a 5th page, and then you get back to a 3rd, you do the 3rd screenshot. So ideally, your state of memory should be the same between first screenshot and 3rd, because you reversed all actions back, you played them back, so actually your memory ideally would be played back. And if you see that there is something, a lot of things not being removed from the memory after that, then it might be also a problem. It's very basics of managing memory. I'm sure you can find very good talk on the internet how to manage memory. But let's go through essentials. Manage your variables with respect. Declare at the top of the scope to increase visibility. Might be not a good idea, but if you build a reliable system, it might be good. ESLint vars on top can help you with that. It's a plugin. Sort for predictability, sort vars plugin for ESLint. Watch for memory leaks, clean listeners and variables when not needed anymore. ESLint, no unused vars is a must-do to avoid declaring variables which are not used. Switch in JavaScript to static memory allocation mode via object pooling might be also an option. Oh yeah, you may wonder, but you may emulate static memory allocation in JavaScript. It's not actually static, but it's the closest you can do with JavaScript. So the thing is that you create object pool, like you need 260 objects of class persona or whatever. So you initially assume, okay, I will need 200 personas in my application. Let me initialize 200 personas to avoid initialization in runtime, to avoid garbage collection and initialization, which is pretty expensive. Then you can get persona from the spool. When you don't need it, release it back and reuse it next time. So all time your application works, there is only 200 personas there. So it's the closest, as I said, to static memory allocation. Rule number 4, all loops must have a fixed upper bound. It's really weird for us, for web developers, but that's what's used in NASA. They don't use infinite loops. So every loop actually have fixed lengths. I don't think we can get a lot of there. It also comes from the rules that they need a predictable, very well analyzed code with static analysis. Rule number 5, the assertion density of the code should be averaged to a minimum of 2 assertions per function. This is basically test well. Assertion is not a unit test, but assertion is something which runs in runtime when application execute. It may say that something goes wrong in an application. They put some checks in runtime, you can do it as well, and manage errors. And higher test density, then less defects you get. Minimal amount of tests is 2 per function. Watch for anomalies in system state during runtime, generate and handle errors in case of critical failures. But if failure is not critical, then it might be a bad idea. Or if something goes really wrong. Measure coverage, but be aware that 100 coverage doesn't not necessarily mean you have well-tested code. Because coverage is basically a quantitative metrics, and it's not qualitative. Rule number 6, data objects must be declared at the smallest possible level of scope. This one we know really well. It might look new, but actually this is about shared scope. It's what web developers are really good in managing, with all this Redux and observables and so on. So mutable shared state decreases predictability, and for the reasons that some parts of application can independently, without notifying each other, change shared state. So no shared state. And here, if you use React, nice thing to try is the ESLint pureness plugin. You can apply to your reducers and basically avoid side effects. Rule number 7, the return value of non-void functions must be checked by each colon function, and the validity of parameters must be checked inside each function. This rule is being brought mostly of the all rules we are talking about today. I mean, NASA engineers say that. They said, this is the rule, we follow the list. It's very right here. Rule number 8. The use of the preprocessor must be limited to the inclusion of header files and simple macro definitions. This is about a C preprocessor, but in JavaScript, we currently use preprocessors heavily. Everybody of you use preprocessor, most likely Babel or TypeScript, but still we should understand, as a JavaScript engineers, we should understand that there is a price for using a preprocessor. When you do, you first create some degradation in performance. So here is a project which compares performance of the features transpiled with Babel compared to native features. And it's still, so a few years ago it was pretty red. Like currently it's getting to a green state, but still sometimes the difference in performance is remarkable. 2, 3, 4, 8 times. So yes, the transpiled code works slower than the code you will write in a plain JavaScript. Be aware. And the second one, the cost of transpiling is also the time of initialization for application and the size of a package. So here is another project which basically compares different bundlers, and we see that there is some difference. File size can vary a lot. It depends on the way it's being bundled, on the settings. Still, transpiled and bundle code is different in terms of initialization and the size. Thank you. Rule number 9, the use of pointers should be restricted. Specifically, no more than one level of dereferencing is allowed. Function pointers are not permitted. Oh, no references. Basically, we can't live without references. But still, there are cases in JavaScript we can apply these rules. And basically, we apply, usually. Oh, number of levels of dereferencing, it's about call chain. And we all know that the shorter call chain is, the less is a chance for a defect. So, yeah, don't use the chains, long chains of referencing, but try to use shorter ones or create variables for long chains. And rule number 9 also says about law of Dimitra. So every object should be responsible for itself. If for managing its inner state, we don't do, it's a common example, classic example. If we want to code a dog, classes of a dog, then we don't say dog body legs run, but we just say dog run, and then dog manages how it's going to run with eyes or eyebrows or hands or whatever. So, yeah, and rule number 10. From the first day of your project, try to consider that this is a JavaScript, and try to consider that you would like to trust in what you do. Try to think about you flying JavaScript airplane. Oh, from the first day of your project, consider the thing you do, the project you do, as something serious, and something which is critical, because it actually is critical. It's critical for your users, for money of your company, for many people around. So keep it green. All code must be complied with all compiler warnings. It's NASA say compiler warnings, but we say about unit tests, we say about coding standards, we say about functional tests, integrational tests. And what if you already fucked up? What if you already read? Oh, don't panic. You'll simply prioritize, test your system model by model, take one model, put tests on it, unit tests, functional tests, apply code guidelines there, second part of your system, and then step by step, you will get it to the point where your system will get to a code quality you're proud of. And the code quality, you will be okay to put on airplane. So being on high requirements, high level of requirements for yourself, it's a small step for yourself, a bit of a discipline, a bit of requirements, but then it's a big step if we do it all together. It's a big step for perceiving JavaScript and web development as a reliable technology, because currently not that many people will do this flight with a web-driven airplane. And let's contribute all together, all of us, to change this, to change our perception of yourselves and our requirements to us, and be better developers in order to one day start to develop for airplanes. Okay, maybe not that far yet, but I know for sure that in Netherlands, there is already a lot of ongoing projects on developing instruments for ships, for pretty serious missions, using HTML and JavaScript. So let's do our contribution to that, and let's be good JavaScript developers. Thank you.